Okay, here's the video from the lesson and practice set that says exponential functions from tables and graphs. So this is set as a suggested due date of May 1st. Ooh, May Day. Okay, so again, some review. Here's our general equation for an exponential function. B is your initial value and M is your multiplier. And as a little bit of an aside, you don't need to write this down as in your notes, but we're kind of always working with these four things in Algebra 1, 2. We might look at a graph or an equation, a scenario, which is also called like a word problem, some context, some story in the table. So what they want to teach you is, given a table, can you find the equation? And down here, they're going to give you a graph, and they want you to find the equation. And so ideally, all of this is interchangeable. So if given a graph, can you think of a story? If you're given a situation or a word problem, can you create a table? And vice versa. So all of this, our whole work in terms of linear, exponential, and then quadratic equation is, given any one of these, can you produce the other forms? So that's kind of what this is getting at in terms of tables and graphs. Okay, so this example gives you just two things. So this kind of goes back to the first practice sets of this week, where I was just telling you to focus on 0 and 1 when you graphed them. So you can also come up with the equation using 0 and 1. So for this one, you know, your B is always attached to that 0. And down here, we'll just do that too. And even here and here. All right. So I know that B is 5. What I have to think of is my M. So my M, again, what you can think about is a multiplier. So I have to think of 5 times what is going to give me 8. So let's do a little equation over here. So 5 times what gives me 8? Well, I need the what. So how do I undo this 5? Well, if two things are multiplying, to undo, we divide both sides. And ladies and gentlemen, it's pretty much as basic as that. So that's my M. That's my multiplier. So yes, it is these two divided by each other, or it's 8 over 5. And then for these, they use x. So I'm going to say to the x. So sometimes we can reduce this or not, but we're just trying to find our M. And so if we need 5 times what number gives me 8, we can work backwards using algebra to find that number. And it looks ugly. If you don't want it like that, you can put it in your calculator. 8 divided by 5 is, you can use 1.6. So another thing that it would work is if you said f of x equals 5 times 1.6 to the power of x. Okay, let's do this one. So B is always my initial value, which is 12 at 0. And then I've got this one right here. So my M, so if 12 times M is going to give me 9, to undo and solve for M, I divide both sides by 12. So ladies and gentlemen, let's see, G of x for this one. They don't care if you're even not in simplest forms. So that works, okay? 9 over 12 is also equal to 3 over 4. So if you want to reduce fractions, both 9 and 12 are divisible by 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. So this is the most reduced. If you want to show it as a decimal, you can do that too. So any of those can go in for M. Okay, down here. So they want you to find the exponential function whose graph is given below, written as this. So if I'm looking here, I'm going to tell you, you're given the graph. I'm going to say make a table and then go to the equation. So we're not going to go straight to the equation. I'm going to make the table like I'd see right here and then go to the equation. All right, so x, and they like h of x for this one. You can always put y. 0, 1. So at 0, we've got 6. And let's make sure at 1, we've got 4. So b is equal to 6. There's my initial value. And then for m, well, we know that 6 times m equals 4. So to undo that, we're going to divide both sides by 6. So m, if we don't want to reduce, is 4 over 6. If we see really quickly that both of those can be reduced by 2, we could also put 2/3, but we don't have to. So h of x equals b, my initial value, times the multiplier, or times the quantity to the power of x. So that's my equation right here. And you know, a couple of things you can think about. Well, 2/3, it better be a decay because it's between 0 and 1. You think of 2/3 of 6, and maybe we have a pretty good understanding of fractions that we can picture that it's 4. And you can always check it on your calculators. So I can say, does that compute? So 6 to the parentheses 2 divided by 3 to the 0. Oh, that's 6. Look, at 0, it's 6. And what about my next one? So that's going to be 1. Oh, that's 4. That's what I got. All right. Let's do this one right here. So my b is equal to 2. And they say f of x for this one. So x, let's just do y so I can show you that y, it's no big deal. 0, 1. 0 is 2, as I saw from my b. And 1 is 6, and they're going to show you that too. So my m, so 2 times some multiplier gives me 6. And that's how, you know, linear functions add each time. Exponential functions multiply each time. So to undo, I divide. 2 divided by 2 is 1. So 1m gives me 3. Also, you could write 6 divided by 2, but 6 divided by 2 is 3. So for this one, y is equal to, my b value or my initial value is 2 times 3 to the power of x. All right, and then the second practice set, or the second exercise, is titled Connecting Exponential Graphs with Contexts, or scenarios or word problems. So you're going to get 3 types of questions for this one, and I've got all examples of all 3 of them. So this one says a computer is sold for a certain price and then its value changes. I even clipped it off because it's just showing this, and it says, how does the computer's value change over time? So, you know, this is what we know. We know we have these x's and y's, and we know at 0, we've got 500. So at 0, there's my initial value right there. Well, what about at 1? Well, I don't like that it says 0.5, so I'm going to follow this up. And I can see what that is. So that looks between 200 and 300. So I'm going to say 250. And that's, so I'm looking at my options here. So first, it says loses or gains. So it does not gain. This is exponential decay from left to right. This goes down. So I'm not losing it. Or yes, I am losing things. Sorry, it's not gaining, it's losing. Okay. So then we've either got 25% or 50%. Well, I feel like they did this to see if you actually looked, because that might be a quarter of it. I'm not sure, and I'm not going to take the time to do that right now. But this is half of it. So it's definitely A. It's definitely losing half every year. And if we go to 2, well, what's half of this? 125? So even if I'm curious, if I go over here, it better be about 125. So make sure you're looking at how it's scaled when you're doing this. So it's A, even though I've got a slash, sorry. It definitely loses. All right, down here, this is a nice one. It says, what's the sample's initial size? So that's my B. Where do I look for B? Right here at the y-intercept. It's 50. Nice. Thank you for that one, Mr. Khan. All right, and these ones, your computer is not that big, so you have to scroll for these, and you really should have some scratch paper, and you can think about what the equation looks like. So Fidel has a rare coin. It's worth $500, and it increases by 20%. So increases. So they all increase. That's annoying. So I can't cross anything out. Let's do the equation. So my initial value, and then I'm going to take 100%, and I'm going to add. So if I do the percent divided by 100, the calculator gives me 0.20. It's really just going to give you a 0.2, guys, but 0.2 is the same thing as 0.20. Okay, so it's only adding 20%, or 80% remains. So let's do 0 and 1. So 0 is 500 because that's my initial value. So that's 1's 500. Ooh, this one is below 500. No, thank you. B does not work. B does not work. This is 500. Ooh, that is below 500. No, thank you. D does not work. D does not work. Okay, so 1. It's kind of annoying. So if I plug in 1, I'm going to get 5. Oh, that's got my tape, so let's do it down here. So I've got 500 times the quantity, 1 plus, it increases by 20%, and 20% is the same thing as 0.2. The 0 does not affect the value, and I'm taking it to the power of 1. Anything to the power of 1 is itself, so that doesn't change. And then, so I'm gonna actually put that in my calculator. So a couple things. If you take 100% and you're adding 20%, I could do that first if my calculator is not so fancy. Again, all of your phones can have downloadable things. So if I just say, well, if I can't, I could do the 1 plus, because I have to do parentheses first, so I can figure that out. So that's 500 times 1.2. So 500 times 1.2. So that's going to be 600. Okay, so at 1, so it's not these two. So at 1, we're looking at 600. So is that 600? Or is that 600? Ugh, they're even pretty hard. So if you think that this is 750, that's right below the 750. So that might be 700. That's not 600, that's 700. So, and this is, you know, that to me I can get behind better. So I'm gonna select C. So you can always use scratch paper, you can always take your notes. And I think that's it, guys. That's it for this week. You should be ready to do, again, this one is called Connecting Exponential Graphs with Contexts. This was kind of the same situation. The suggested due date is for Friday. And then this one, oh, and then this is the other practice set called Exponential Functions from Tables, Tables and Graphs. So those are some examples that'll help you do that practice set. I miss you. Bye.